this is figure 4 from your textbook. So now let's go ahead and say that we've got this leaf right here, and we want to find the area of the leaf. So we go ahead and we take a picture of it, okay, and that's what we've got. And then what we might want to do is take that picture and estimate the area. So let's say we want to estimate the area. Because this figure over here is a very difficult figure to get an actual area because it's not a nice straight line. It's got all these curves and all these jagged edges. So we just might need an estimate. And for the purposes of obtaining the area, maybe we only need some estimate within some certain degree. So here's what we're going to do. We're going to take that picture and we're going to subdivide it up. Okay, and this is what your book does. Okay, so we're going to go ahead and draw some nice even lines. Now I'm not going to be able to do this as good as your book does. Okay, actually let me go ahead and erase those. Guys, let's draw those just a little bit better. Okay, I'll try to draw them a little bit straighter here. So let's put one at the edge here. Okay, and let's go ahead and 2, 3. Okay, that looks pretty good right there. Okay, so it looks, at least it looks fairly even, right? Okay, so here I've got my 1, 2, so 1, 2, 3, 4, 5 division lines. Let's come back across the other side with it. So let's box off the top. So let's put 1, 2, 3, 4. Okay, so we've got our 5 sections. Excuse me, I've got 25 sections altogether here, but I've got my 5 lines coming down. So let's go ahead and say maybe for our estimate, we want a lower estimate for the area. You can think about this as like a lower bound, a least estimate. We might want to say, well, let's take a look at all of the squares in here, rectangles, that are completely filled with a leaf. So our lower estimate will be the ones that are completely filled. Well, how many do I have? Well, if you look through here, there's really not that many that are completely filled. Now, this one here in the middle, right here, this guy is definitely completely filled. And you might argue that this one right here is completely filled, although we've got this little section right here. So let's just say there's only one of these guys. Okay, because that's true. There's only one that's completely filled. So that's like a lower bound. So we might say, I don't know, I think, you know, your book says that each of these is like a centimeter or something. We might say, okay, well, out of the 25 cubic, out of the 25 square centimeters, only one of them has a full area, so we'll say the total area of the leaf is 1 square centimeter, or centimeter squared. Okay, and then the upper estimate, maybe instead we want to say, okay, well, how many of them have at least a part of a leaf in them? So let's count those. I'll mark those off in green. Actually, let's do it in purple. So which ones have part of a leaf? Well, it looks like this guy up here does. This guy here. So we'll just go ahead and mark. Now, we'll mark this, right, because we still have the leaf here. I guess I didn't say including the stem. Oops, and still we need this guy. So I think I've got them all checked. Well, let's look at the ones that don't have anything in them. So here, here. This looks like a bad game of tic-tac-toe. Here, here. Okay, so our upper estimates, okay, is going to be all of these purple ones. So they're all the ones that contain at least a part of the leaf. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So that are, well, these were completely filled, so we'll say at least partially filled. You know, I lost my number again, so let's count again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So we might say an upper estimate for the total area that the leaf is enclosing here is 18 square centimeters. And so the true area, let's call that A. We know that the true area A is somewhere between 1 and 18 square centimeters. And so then the next thing that you would, I guess, that naturally would come up is to say, okay, well, look, what if we did a better job of dividing this guy up? So let me go ahead and erase what's here. And that's what they've done in Figure 5, is they've broken it down even further. But now let's say, I think they probably use something like 10. Okay, I'm not going to be able to go that far, probably. Let's see how many I can put in here. So let's go 1, 2, 3, 4, 5, 6, 7, 8, 9. Close enough. You guys get the idea. 1, 2, 3, 4, 5, 6. And so if I start dropping lines down here, these got a little bit bigger over here. Okay, but we're just trying to get the point across. Now by subdividing it even further, what I'm going to get is a better and better approximation of the actual area. Now the amount of subdivisions depends on how accurate we want to be. So again, we could go through here and count all of the boxes that have that are completely filled by the leaf. And so if we go ahead and do that, let me put those in blue here. This guy, that guy's close. We'll give it to him. Now these are no longer square centimeters, right? Because these are a little bit smaller. But again, we could go ahead and we could count all of these. I'm not going to go ahead and do this, okay, because I think you get the idea. But we'd count all of those blue, and we'd say that that is our lower estimate. And then we would add to that all of these green here. Wherever I see a leaf poking in, or at least a piece of the leaf poking in, I grab all those guys. I suppose I should include the stem. Okay, looks like all that. And so if you take the blue plus the green, that gives us an upper estimate. And that's the idea. We're just trying to approximate an area by using little rectangles or little squares. And we'll end up doing that a lot throughout the course, especially once we start to get into the integration portion of the course.